All right, so we started on Monday we started talking about energy, right? And the two main that we focus on have to do with how high you have something off the ground, right? And then how fast something is traveling, right? What is the energy that has to do with how high something is off the ground?
More potential energy.
Right, potential energy, right? So how high I raise something off the ground, that has to do with, it's more specifically called gravitational potential energy. All right, but it's potential energy. Again, it has to do with the height of the object. Okay? So, what about how fast something is traveling? What type of energy is that? Right, it's kinetic energy. Right? So, depending on how fast something's traveling, that determines what your kinetic energy is. How much kinetic energy do you have if you're stopped? None, right. That's important to think about. Same thing as momentum. If you have no momentum, right, if you're not moving, you have zero momentum. Okay? Do you see how the momentum and kinetic energy are actually related? Momentum, we know, is P equals mv. Kinetic energy is 1/2 mv squared. Right? So they're actually very related. And there's a thing, if you take calculus, where if you take the derivative of the energy, you get the momentum. Right? There you go. So, calculus. So, we've got those two. Now, let's say, and we talked about just lifting it up, right, changing its potential, and then throwing it and changing its kinetic. But what if I do this, right? What if I throw it, and it goes up, and then it comes down, right? So it goes up, and then it comes down. So what's changing, if we think about just in terms of going up and down, is the potential changing? Okay. What about so the potential is changing because it's going up and down as it travels. What about in terms of its speed? Is the speed of it changing? Yeah, its speed is changing too. So when I throw the ball, really what happens is I get the kinetic changing at the same time that the potential is changing. That makes sense, right? And that makes sense, right? Up and down and speed's changing at the same time. All right. As it's going up, what's happening to the potential? It's increasing, right? Right. So the potential is increasing as it goes up. And then as it's on its way down, what happens to its potential? It decreases. All right. What happens to the speed of the ball as it goes up? It slows down, all right? So what happens to the kinetic? It also decreases, right? So as it's going up, it's slowing down. The kinetic's changing, right? It's going down, it's decreasing. But as it's falling, what happens to the speed? Increases. So what happens to the kinetic? Increases as well. All right, so you just told me that while the potential is increasing, the kinetic is decreasing. And while the kinetic is increasing, the potential is decreasing. Okay? So that's this thing called conservation of energy. All right, so what's happening is this ball has a set amount of energy, right? And when I throw it, it gets that energy. I'm giving the energy to it. I'm doing work on it so that it gets its energy. And it can't lose it, right? It can only go other places. So in this case, the energy that I give it by the work I do on it, it changes it from kinetic to potential, and then potential back to kinetic. Does that make sense? So it has a set amount. The law of conservation of energy says that I can't create it, I can't just make stuff new out of it somewhere, and I can't destroy it. But I can change what form it's in. Does that make sense? And whatever I have to start with has to be whatever I end with. A little nervous there, huh? Okay. So whatever I start with has to be whatever I end with in terms of total energy. Right? So what the equation says for conservation of energy is that the sum of my potential and kinetic that I start with has to equal the sum of my potential and kinetic that I end with. Okay? Does that make sense? Okay? No matter where. And it could be, momentum, we were talking about collision, so it was before and after. Right? But energy, it could be anywhere. Right? It could be anywhere in the flight of a ball. The total energy has to be the same no matter what. Right? So this is the total energy. And this has a special name, the sum of the potential and kinetic. We call it mechanical energy. Right? So mechanical energy is the sum of the potential plus the kinetic at any point. Does that make sense? Okay? So that's conservation of energy, really, is just that the amount has to stay the same. We can just convert it into different forms. Right? If we talk about like the lights, right? The energy that we get from the lights in terms of light and heat and a little bit of sound too, you can hear them buzzing. That may have started as kinetic energy. That may have started as potential energy of water at the top of a mountain. And as it came down the mountain, it lost potential, but it gained kinetic. And then that kinetic energy that the river had caused some paddles to turn, which gave that kinetic energy. And it went through a generator, which created electrical energy. Right? And that electrical energy is then transformed into the light, the heat, and the sound that we get from these lights. Right? So whatever we started with potential, right, those little drops of water on the top of a mountain, all got transferred into the energy that we need for these lights. That make sense? I'm kind of like mind blown, like, oh my goodness, right? It's kind of deep.
That was like one of those commercials.
One of those commercials?
Yeah.
Okay.
You know the ones. It's,